Hi, so in this video we're going to talk about prisms and then calculate the volume of them. So if you don't know what a prism is, I'll explain that to you now. It is a three-dimensional object where two of the ends are identical and it's made up of flat faces. Okay, so if you're sat at home and thinking what the question which every maths teacher loves to hear, when are we going to use this in real life? We just all love to hear it. I'm going to show you because prisms actually come in to real life quite often. Okay, so let's go on a hunt for prisms around my house. Okay. So we're going to go hunt for some. Oh, this is so convenient. It's almost like someone planned that this was going to have a whole bunch of prisms on it. Okay, so here we have one, and hopefully what you can see is that this shape is a trapezium, and right at the other end is a trapezium, and if you cut that at any point, if it was solid, you would always see a trapezium, so that means that is a prism. We've got another one here. So at this end, we've got a triangle. At this end, we've got a triangle. If you cut that any way along, you would always see a triangle that way, which therefore makes it a prism. This is an interesting one. We would actually call this shape a cuboid, but that actually means it is a prism as well, because if you cut it any way along there, you will see that it is a rectangle. So this, even though it's a cuboid, we could also call it a rectangular prism. And now we're going to come to a shape which some people think is a prism, but technically isn't. However, the volume of this shape is calculated the same way, and that is a cylinder. So we see here, it is a circle on that end, and it's a circle here, which means that any way you cut it, you'll always get a circle, which means a cylinder can be calculated the same way as a prism, but by the definition that it's only made up of flat faces, a cylinder technically isn't a prism because this is a curved edge. But now we've seen some prisms in real life, why don't we go back and calculate the volume of them. So here we are. So volume equals area of the cross section times height. Cross section is the name for that, the shape that wherever you cut it will make. So for this one, which we can imagine is the Toblerone box, where we cut that along that direction, you'll always see a triangle. So the triangle is the cross section, and then the height is just the length of the prism. So that means the volume is just going to be 15 times 10, which is 150, and its volume, so it's centimeters cubed. Okay, so this is one that is like the chocolate that wasn't a trapezium, the Toblerone. It was a Swiss chocolate one in the video. We know the area of the cross section, which is a trapezium. We know the length of it. So we do volume equals 6.5 times 4, which is going to give us 4 times 6 is 24, 4 times 0.5 is 2, so it's going to be 26 meters squared. Okay, next one, even though it's not technically a prism, we can calculate the volume of it because we know that that's 10 and that's 25, so it's going to be 10 times 25. So it's calculated the same way, but it's just not technically a prism. So it would be 250 centimeters cubed. Oof, done that one wrong. How embarrassing. Okay, for a bit of an extension, these three questions I've given you the area of the cross section, but you're not always going to get that. So if we look here at this one, what shape is the cross section? It's a triangle. Do we know how to calculate the area of a triangle? Yes. So area of the cross section will be a half times base times height, if you remember the volume, the area of a triangle. So half times 6 times 8. 6 times 8 is 48. 48 divided by 2 is 24 centimeters squared. So now we know that that's 24 centimeters squared. So let's calculate the volume, which is going to be the area of the cross section times the height. 24 times 2 is 48, times 10 is 480 centimeters cubed. Okay, so that's how you calculate the volume of a prism.